Welcome to another video on the C programming video series for the beginners. In this video, we will continue talk about the variables. In the previous video, we have tried to visualize the variables as boxes. In order to continue with this video, you have to watch that previous video, then you can continue. So here in this video, first we will talk about bit and byte. A bit is the smallest piece of information in a computer. It can only have one of the two values, either 0 or 1. In the hardware level, you can think of this as a switch. If it is off, we can say 0. If it is on, then we can say 1. Think of it like a light switch. If the switch is on, then we can say 1. If the switch is off, we can say 0. The computers use billions of bytes to represent all kinds of data. Every digital information is saved in the form of zeros and ones. Why? Because it was the only possible way we could implement it in the hardware level. Imagine them as the switches which will either be on or off. Now here, imagine every single box as a bit. So every box here in this particular image is a bit. So it will either contain 0 or 1. Now, as I said before, every digital information is represented in the form of zeros and ones. For example, this video that you guys are watching, it is stored in the YouTube server in the form of zeros and ones. Every digital information is stored in the form of zeros and ones. A group of 8 bits is called as a byte. So 8 bits is a byte. 8 bits equal to 1 byte. Similarly, if we have 1024 bytes, it will be called as 1 kilobyte. 1024 kilobytes is called as 1 megabyte. And similarly, the list goes on. Gigabytes, terabytes, etc. Now here, let us assume that this particular box that I have drawn, which I am highlighting here using the cursor, let us say this is a sliced image that we have taken from the memory. So there are memory cells above and there are memory cells below. And here, every box is a byte. So every box here you see is a byte, and 1 byte has 8 bits. So here 1 byte will contain 8 bits and we have several bytes here. The modern computers are byte addressable, which means that every byte will have an address. So here, as I said before, this is a sliced image and there are memory cells before, there are memory cells after. Now let us say this byte has the memory address 101. Next byte will have 102, then 103, 104, 105 and like that. Now when a program has to store information, it has to be stored in the computer memory. A variable can be imagined as a box where we can store information. So here everything will be stored in the computer memory, and a variable can be imagined as a box which can store the information. Now in the previous video about the boxes, we have seen that for storing smaller item, we can have small boxes. For example, for storing a pair of shoes, we can have a small shoe box. For storing a TV, we need to have a large TV box. For storing a fridge, we need a large fridge box. So similarly, depending on the value that we want to store, we need to have different number of bytes required in order to store that information. So let us say in our C program, we want to store the age of a person. And this age value will be a whole number, a number without any decimal places. What we do is we tell the C language that we want to store a whole number. Now let us say in order to store a whole number, we need 4 bytes of memory. What the C language does is it allocates 4 bytes of available memory for us in order to store the whole number. So if you remember about the boxes can have a name. So this block of memory, which is allocated for storing this whole number, can contain the name as age, and the boxes will have address. So here in this case, the address will be the address of the first byte of the block which is allocated. Here 4 bytes are allocated for storing a whole number, and the name will be this age. Address will be the address of the starting byte or first byte in this block. Similarly, let's say we want to store the height of the person, and let us say this height of the person is a real number, a number with the decimal places, and in order to store this information, let's assume that we need 8 bytes of memory. So what we do, we tell the C compiler we want to store a real number, a number with the decimal places. What the C language does is it allocates 8 bytes from the freely available memory. So let us say this much memory is freely available. So this memory block will be allocated for storing the height of a person. Now the name can be this height, address will be the address of the starting byte. In this case it will be 105. So imagine it just like the boxes. Boxes will have a name and an address. Similarly, the name will be this height and the address will be the address of the first byte. Now let us say we want to store the grade of the person. Okay, and it will be a character, single character, let us say A or B or something like that. Now what we do, we tell the C compiler we want to store a character value. Now assume that in order to store a character value, we need only 1 byte of memory. What the C compiler does, it allocates 1 byte of memory from the freely available memory. So let us say this one has the address of 120. So this block will be allocated for storing this grade value. Name of this particular box will be grade, and the address will be this address of this byte. Now this is really an important concept. Just remember that every bit can contain either 0 or 1. 8 bits are grouped together and they are called as a byte. Every byte will have an address, and when we have to store certain information, depending on that information, different number of bytes are allocated for them. In the next video, we will see how we can create a variable, how we can store values in them, how we can access the values. So this is it guys for this video. Thank you for watching. I'll see you later in the next one.